Assalamualaikum and good day. Today we try to continue about the other optional in the refrigeration system. As we know, we have several type of the uh, refrigeration. We have several list there, so we can choose one of the type of the application of refrigeration. Depend on the condition of the uh, uh, application of the refrigeration itself. Yeah. So maybe in the industry, we can this one maybe one optional before we choose. So we have several consideration, and then we have several condition before we choose this type of the hatchback system. Yeah. So we go one by one, yeah, by to introduce the abstraction definition first, yeah, then the principle of the abstraction, and then we go to the components, all the abstraction application, yeah. So now this one is already in the lecture 6, yeah, from the uh, introduction, yeah, of the refrigeration, yeah. Actually, this one is under of subject refrigeration system design, yeah. So we go first in definition, yeah, and principle of the absorption refrigeration system, yeah. A type of absorption system, yeah, use heat energy to produce refrigeration or heating, and sometimes to elevate the temperature of the waste heat. So actually, we can utilize the waste heat from the activity, uh, like the industry, not only industry, maybe from the geothermal, yeah, that available in the nature, and then we can utilize this thermal to develop one refrigeration system. Yeah, then we call this one is the absorption system of refrigeration. Yeah. So actually in the system we use one liquid, yeah, to capture of the refrigeration, and then also to spread within the water system. So they use one chemical that they call aqueous lithium bromide, or they call in the uh, short term in the LIBR, lithium bromide. It's often to use to absorb the refrigeration, the from the water vapor, and provide a higher coefficient of performance. So once they used, and then they will capture and then make a crystallize of the refrigerant, and then again the refrigerant will be separating within the water. Water will be a filter, using the filter, and then release to the piping system, and then they will storage the water, and then will be used again for the coolant system, yeah, again to the to generator to create the heat, yeah, and then back again, and then they will cycle again. Okay, current absorption system can be divided into the following categories. Yeah, the first one, absorption chiller use heat energy to provide refrigeration. So they will use the absorption chiller. Yeah, and then they use also absorption chiller heaters. Yeah, so this one is a different type of the absorption system. And then they also have absorption heat pump. Yeah, extract heat energy from the evaporator to the absorber. So totally depend the uh, the plan, yeah, how the plan we will use, whether we use a chiller heater, or the absorption heat pump, and then also absorption heat transformer elevate the temperature of the waste heat to value higher than any other input fluid stream supply to absorption heat transformer. So this one is more complicated. So actually, relate to the cost, for the absorption system, maybe for the initial investment will be have the higher compared the normal refrigeration. So uh, maybe this one will be used in the for the biggest the refrigeration, yeah. So that's why we can invest more higher in the costing. So but in the operation will be maybe will be low cost, yeah, but only for the first time of the cost will be have the higher of the cost, yeah. So a cost analysis is often required. So this one is one already recommended. They have one research, yeah. Uh, we call the Oman in the 96, yeah, recommended that in addition to the chiller itself, the energy and initial cost of the auxiliaries, such as condenser, pump, cooling tower, and tower fans, be included in the cost analysis because of the higher heat rejection in the absorption chiller. So because they have maybe for the big plant, so they will be have a biggest of the size of the auxiliary, yeah, auxiliaries, yeah, like the pump maybe is higher, maybe a cooling tower also higher, because will be use the a big plant. So we try to absorb the heat. Yeah, it's not easy. Yeah, they have the generator to create the boil and then try to boil the water and then change to the vapor, and vapor will be transport. Yeah, use as transport the refrigerant. Yeah, and then this vapor will create a high pressure and then will be allowed to transport the one cycle. That's why we use the heat, yeah, for initial energy to replace the compressor. So maybe one of the component, yeah, differentiate within the normal refrigeration and within the absorption system is maybe we can uh, use without the compressor. Yeah. Okay. Another research. Yeah. This one. The auxiliary energy cost can be 30% higher for the isolation chiller than for electric. Yeah. So we can take a note. Yeah, because this system will be absorbed. Yeah, 30%. Yeah, of energy, and then the sun is also have research they compare, with two design for the project, yeah, within 1,200 ton and 400 ton. So what differentiate within this system? Yeah, the electric centrifugal chiller and the other is two electric centrifugal chiller plus absorption chiller. The cost of gas, yeah, so they come out with the price, yeah. So the price. So in the summer, they cost, their cost is around zero. This one in cent, yeah, in cent dollars. So 46, yeah, 46 cent dollar per term in summer. Term mean term mean sorry, term will be explained as. Sorry, I will find the term. Actually, term mean that the BTU, what? Yeah, equal. Okay, this one. One term is equal to 100,000 British thermal unit, yeah, per hour. So mean that we will burn the energy is 100,000, yeah. Then the price is 46 uh, cent, yeah, in dollar. So mean that will be get a low price, yeah, by operate using the uh, system, refrigeration system, by absorption system. And then in the winter, yeah, they will be 50%, sorry, 50 cent dollar per term in winter. So different, yeah, different price because yeah, you know, as we know, the winter will be have low temperature, so maybe need more energy to boil the water. Yeah. So application, yeah, the absorption system, yeah, according to the aircon system, yeah, air conditioning or HVAC, yeah, April 14, yeah, shipment of the new absorption chiller from the manufacturer in the United States in 1966, yeah, number blah blah blah, this one, 579. The shipment of centrifugal and screw chiller, yeah, number this one. So actually this one is a application by using this, yeah, auxiliaries, yeah, and then the chiller is 50% of the new large chiller market in the United States. Yeah, so this refrigeration is considered a big design. So mean that consider in 5% of biggest of the uh, chiller market. So the chiller have the advantage using gas and therefore not affected by the higher electric demand charge and high unit rate on peak hour. So by using higher chiller size, so will be reduce the uh, energy uh, 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 energy using. Yeah. So that's why by using this one, because this type is higher, so maybe will be more effective, yeah, consider to a small refrigeration system. Okay, this one is a structure of the absorption system. This one is complicated, more complicated. Okay, consider is a absorption. Maybe we try to create one generator from the heat waste, yeah. And then we try to absorb and then to boil the water, and then this water will be create one uh, higher pressure. Once the higher pressure will already created, and then the transformation will be work, yeah, and then the cycle will be starting, and then the starting will be create one cycle, yeah, and then together with that, yeah, we try to use uh, refrigerant, yeah, to create the transformation of the cycle, and then together with the refrigeration, and then we try to uh, using, yeah, or you utilize, yeah, this condition, whether we use as a heater or the cooling system, yeah. Okay, system one cycle of the absorption system. Maybe we can start, yeah, from the evaporator and refrigerant pump. The evaporator is composed of a tube bundle, an outer shell spraying nozzle and water through, and then the chiller water from flow inside the tube. Yeah, so refrigerant pump spray the liquid refrigerant through the spray nozzle. So actually, this one is for cooling system. Yeah, for cooling system, they try use the spray nozzle. Yeah, to make a low temperature system when utilize the uh, uh, absorption system. So they use the refrigeration, and then this temperature cooling by refrigerant, and then they spray by using the spray nozzle, by using the pump, and then once the ready uh, low temperature, and then they try to distribute using evaporator or using the duct system, and then they try to distribute the system. Absorber and solution pump. Absorber are water cooler tube bundle with cooling water flowing inside them, and the absorber, the vaporized refrigeration, the water vapor is extracted and then absorbed by concentrated lithium bromide solution spray from the nozzle, so that high vacuum. So as I mentioned before, we use the one solution, chemical solution, to capture the refrigerant. So once already utilized, the low temperature, and then we try to separating within the absorber and water, and then we use another chemical, and then make refrigerant in the crystalline, and then we filtering, and then after that we allow to storage both refrigerant system and then water system. Okay, heat exchanger. Okay, heat exchanger we use in the absorption system. So heat exchanger are sometimes called economizer, shell and tube or plate and frame heat exchanger are most commonly used for greater effectiveness. They are two heat exchanger, low temperature heat and high temperature heat exchanger. So when we utilize for high temperature, we use the high temperature heat exchanger, and if we utilize with the low temperature, and then we use low temperature heat exchanger to uh, uh, transfer heat within the liquid, and then with the with the refrigerant and then coolant. So in the heat exchanger, we change transform the both fluid of heat condition of the heat or temperature. We transform in the exchanger. Generator, as mentioned in the figure in the previous class, a previous slide, the generator is to create the high temperature or to boil the water, and this one we call the generator. And this from the generator will be create the high pressure, and then to allow the cycle work. Condenser, same like the normal of the refrigeration system. Condenser will be used. Uh, in this case, condenser is water cool tube bundle in which cooling water flow. So condenser will be released or rejected the heat. Maybe to the uh, environment. And then also we use the throttling device, to reduce the pressure. Automatically we will reduce the temperature. Same like the normal refrigeration. Okay, in the refrigeration they have a series flow and parallel flow. This one is depend on the uh, water system, whether we want to implement the series flow or the parallel flow. Okay, how to measure the coefficient of the absorption itself, by formula COPH, because H is will be uh, mentioned to the heat, thermal. So we use this formula QAB plus Q condenser. AB mean the absorber, and then over to the HG. HG mentioned to the heat input high temperature generator. So actually same thing like the from the lower temperature to the higher temperature comparison ratio within the how much within the temperature from the low, from the rather high. So if have a much differentiate will be create the high efficiency. So should be greater than 1, yeah. So after calculation should be greater than 1. So this one example, Japan and Sweden is will be get receive achieve under 1.2 and 1.7, yeah, of the coefficient. This one is the case study, yeah, for the absorption study. Uh, so they have the schematic and for the uh, describe, yeah, this study case, yeah. They have a 50 megawatt series connected absorption heat pump installed in the incineration plant in the Uppsala city, Sweden, yeah. And then the series connected absorption heat pump consists of two single stage sufficient heat pump, each with a evaporator, absorber, generator, condenser. So same, they use the normal auxiliaries, and then they use and then get the COP 1.61. Yeah. Okay, I think that's all for absorption. Yeah, absorption refrigeration system. Yeah. Please make sure you answer the quiz, yeah, after the video, and then this uh, answering quiz will be considered as your attendance. Okay, that's all for today. For one optional condition before we try to uh, uh, design, the refrigeration system. This one is one of the optional system. Okay, Assalamualaikum and good day.